All right, so in this video, we're going to look at numbers 16 through 20. Okay, so let's go ahead and begin. Number 16 says, compare each function with the parent function without graphing what are the vertex axis of symmetry and transformations of the parent function. So looking at this original equation, even though we're not graphing, what we want to do is concentrate on this b value, otherwise the coefficient of x, and we want to get it to 1 because it's 8 right now. Let's go ahead and get it to 1 by factoring out from both 8x and 7. We're going to factor out an 8. That means we're just going to divide it out. So dividing it out, we'll have 8 parentheses x, and then this is a positive 7. Positive 7 divided by positive 8 will become positive 7/8. And yes, if we were to redistribute, you could check it out and get 8x plus 7, because 8 times 7/8. The 8s would cancel and the 7 would be left. So hence we would get the original stuff that's inside of the absolute value piece. So that's a good way to check it. All right, so in the absolute value piece, what we're going to have now is this negative out in front and then this -2. So this is our equation that we're able to do it. Now, we're not graphing it, but from here what we need to do is see where does that horizontal shift to the left or right actually occur. And we're analyzing that from that C value. So again, with x, we do the opposite. So the axis of symmetry is going to be at x equals negative 7/8. Okay. So we know that it's not going to be B or C, but it could be, in fact, A or B could be an answer. Okay. So let's look at the actual vertex. Remember that the vertex does come from two values, the x and the y. So that x is that shift left or right that occurs, which we've already accounted for, which is negative 7/8. And then we have to look at the d value. This is the vertical shift up or down that occurs. Just remember that the absolute value is always at the origin in its default stage. Because this is a -2, we know that it's going to end up moving down 2 from the 0 that it would normally be at. So from 0, 0, it shifts 7/8 to the left, hence giving us a negative 7/8, and then a -2, which is going vertical shift down 2 units. So D would be the answer. And yes, you could see the reflection across the x-axis also is shown by this coefficient in front of the A value. Okay, so D would be the answer for this one. All right, let's go to number 17. It says transform each of the following by horizontally stretching by 2, then shifting 7 units to the right, and then finally 1 unit down. Okay, so this is not a multiple choice. In fact, we have to do every single one of these step by step. These are the ones that I was talking to you about in class as far as what I needed to clear up with you. So f of x is the y value, and x alone inside here is the x value. So anything that's done horizontally is going to affect just the x, and anything that's done vertically is going to affect the entire f of x, like the entire y value. Okay, so the entire y value, and then the horizontal is just the x. Okay, so let's look at A. If we're going to stretch this horizontally, that means we're going to be with the x. What we're going to do is basically stretch it horizontally. Remember, with the x, it looks opposite. We're going to go inside with the x, and it would look something like this. So this f of x will become f of 1/2 of x. Again, at first glance, this 1/2, it is horizontal because it's with the x. But at first glance, it looks like a compression. But because it's with the x, we do the opposite. So it's not going to be a compression. It will, in fact, satisfy this stretch by 2. So how do we do this on the equation over here? Well, just where x is at, we're going to put a 1/2 x. Where x would normally be, we're now going to put a 1/2 x. Everything else is still the same. The absolute value -4 plus 3. This is all going to be now g of x, because this is the change that occurred. But again, just the x that we're affecting, we're going to do this 1/2 x. All right, so now from here, we're going to shift 7 units to the right. So if I were to look at it from this state right now, and I find that it's going to be a horizontal again, I'm only going to look and concentrate on just the x. So right now, what I'm going to do is I'm going to keep this as 1/2. And then instead of putting x, I'm going to do this new one. Let's do it in blue. This horizontal shift 7 units to the right. So where x used to be, I'm now going to shift it 7 units to the right. So instead of just having x, I now have x minus 7. Okay? And then from here, what I'm going to do is end up 1 unit down, shifting down. So if I have this graph over here, and it's still -4, and normally it's +3, since it's a vertical shift 1 unit down, it's like you're vertically shifting this by 1 unit down, means this +3 is going to become a +2. Because you're shifting it down, the 3 would go down just by 1, and it would become a +2. Okay, so now when we simplify, we're going to get this as, and you can leave it like parentheses, but if you simplify it, it will be 1/2 x minus the distribution, which is 7/2, and then it's still -4, and all of this is in the absolute value. Okay, so if I were to simplify this -7/2 minus 4, if I were to get a common denominator, multiplying it by a form of 1 would be 2/2. So this is -8/2. And it's -7/2 minus 8 is going to become a -15/2. So these two combined together will simplify to 1/2 x minus 15/2. And then everything else is still the same. +2, and then you have your g of x. So this would be your final answer. Again, remembering that we were doing just x each time that we were going and concentrating on what it would be. Okay? All right, so with that now being said, let's go on to the next one, which is letter B. Okay? So letter B, let me make a little bit of room. Again, we're just concentrating on those x's with those horizontals, and we're affecting the entire y value when we're looking at the verticals, stretches, compressions, and so on and so forth. All right, so let's go ahead and go to, let me erase all of this. I think 17 is a huge example for you to practice as far as in preparation for the test. So we're going to horizontally stretch this by 2. So where x is normally at, we're now going to put 1/2 x. Okay, and then everything else is still the same. The absolute value plus 10, and then -6 with this reflection over here on the outside. And then the next thing that we're going to do is shift 7 units to the right. So again, horizontally, we're going to go and gravitate just where x is at. And where x used to be, we're now going to put x minus 7. Everything else still stays the same, the 1/2, and then everything as far as a negative absolute value. And then you will see a plus 10 right here, closing the absolute value in -6. So this is your answer here. The distribution, again, could give me 1/2 x minus 7/2, and then plus 10. And this is still inside of the absolute value. And then it's -6 on the outside. So a -7/2 plus 10, practice without a calculator with fractions. We will multiply by a form of 1 so that we get -7 plus 20, both over 2. So now we can add, since we have common denominators, and get a positive 13/2. So this will become 1/2 x plus 13/2. That's still inside of the absolute value with a negative reflection out in front and then the -6. The last thing we just have to do is shift 1 unit down. So whenever I do 1 unit down, I'm just going to subtract this y value right here where it used to be at -6. And by subtracting it 1 unit down will become a -7. So again, think of this as y, like the x coordinate here in the y or x-axis and the y-axis. If you're at a -1, 2, 3, 4, 5, 6, and you were to shift down by 1, you would become this -7. And that's how you get g of x is equal to the following. Negative absolute value of 1/2 x plus 13 halves minus 7 on the outside. Now let's go ahead and move on to C. Okay, so now let's go to C. Okay, so we're going to go to C, and still doing all of these same transformations as far as what was given in our instructions, but we're doing it for 4 of these equations, okay? So let's go to first horizontally stretch this by 2. Okay, so that means everything else is still written, again, like normal. So we have h of x is equal to 2/3 negative plus 9 plus 15. And again, like I said, where x used to be, we're now going to put 1/2 x. This is accounting for that horizontal stretch by 1/2. Okay. And then from here, I mean, let's say if you were to simplify, you would still get this, okay, to where you're still going to look at this x on the next step and do this 7 units to the right, okay? So let's go ahead and do that right now, but in color coordination. So we have 1/2 still here, and where x used to be, we're now going to shift 7 units to the right, okay? I'll close out the x from the step before, and then everything else still remains the same. Plus 9, or sorry, a negative, and then plus 9, and then 2/3, and then finally the plus 15 on the outside. And then last but not least, 1 unit down, let's do that in orange. The 1 unit down is going to subtract from this 15, so it becomes basically plus 14. And then everything else just simplifies. So this 1/2 can distribute first. So it's going to be like 1/2 x minus 7 halves. And then you can distribute that negative on now both of these terms because you still have this inside of the absolute value sign. This is 2/3. This is still h of x. So you'll have a negative 1/2 x. Then a negative times a negative is a positive. And then it will be a positive 7 halves plus 9. And then you still have this 2/3 out in front, and then this plus 14 on the outside. And then last but not least, what we're going to do is combine like terms in the inside as far as these two constants. And again, I'm going to multiply by a form of 1, which is 2/2, so that I get 18, because you're multiplying, over 2 plus 7/2. Okay, and that's going to give us 25/2. So we'll say 25/2. Let me go ahead and move that right here. And then it's negative 1/2 x plus that. And then we have plus 14. And then we have 2/3. And this would be h of x. Okay. And sure enough, like I said, this would be the simplified answer with everything distributed, the parentheses on the inside being simplified, and you would end up with h of x is equal to 2/3 times all of this. And looking at the key right now, it seems that it's a little bit different. I believe in the key that there was a mistake made on the one that's handwritten, where it had this negative 1/2, and it was like x minus 7 on the inside, and then it had plus 9. When you distribute this, it looks like on the key it was mistakenly written as a negative 7 halves, where it should have been a positive 7 halves. That's why when I add it with this 18 halves that we were looking at over here, you do in fact get 25 halves, which this is the correct answer for C. Okay, so now let's go to the very, very last one, and let's now do D together. All right, so I'm going to leave this as far as set up ready for our next one. Let me erase all of this. And then we'll just go through it one step at a time like the other ones. All right, so we have, oh, this is just a little bit different actually. So we have, this is k of x as well. Wow, it's drastically different. Oops. Switch to, there we go. All right, so we have k of x is -4. I'm going to leave a space where x is at, and then -11 on the very end. So where x used to be, I'm going to stretch it by 2. So it's going to be 1/2 x. And where now this x used to be, I'm going to shift 7 units to the right. So everything else is going to stay the same as of right now. So negative absolute value of 4, 1/2. I'll leave a space. -1, -11. This is k of x. And now where this 1/2 used to be, I'm now going to shift 7 units to the right. Okay, so let's do that in blue. So again, where this x used to be, we're now going to shift 7 units to the right. We'll have to do it in this small little parentheses. And then last but not least, we'll shift 1 unit down, which this one, it's going to be -11 minus 1, which of course you're just going to add those two together and get a -12. So that one's the easy one. And then now we're just going to distribute this 1/2 first. So we'll get 1/2 x minus 7/2. And then we still have to distribute now this 4. And then the rest of it is still just as copy down. So -1, absolute value, -12 on the outside. And this is k of x. So this will become 4/2, which is 2. And then 4 times -7/2 is, again, like 4 over 1. So it'll be -28 over 2 minus 1. And then -12 on the outside. And then combining like terms, still this -28, okay, over 2 minus 1. We're going to multiply by a form of 1 to get a common denominator. Again, remember, you do this when you're adding or subtracting fractions. So we'll have a -2, because 1 times 2 is 2. So it's -28 minus 2 all over 2, which will give us a -30 over 2, which simplifies to -15. So 2x is going to be here, and we're going to say minus, here we go, minus 15. And then we have the negative on the outside, and then we have 12, and this is going to be k of x. So this would be our final answer right here. Let me go ahead and box it up. Right here is our final answer for part D. All right, so again, this one right here, in my opinion, is the one that I needed to clean up there at the very end and make sure that we understood, those are stars, by the way, that as we're doing it through the problem as far as step-by-step transformations in words, that we do, in fact, if we're affecting just the x, that we do replace just the x throughout the problem with whatever we're needing to do. Just like we did here with the 1/2 x, and then we just kept following through with the next step as far as shifting 7 units to the right. So 7 units to the right would look like this. Just for that new x placement, that 1/2 still stayed the same as it was. And just like you saw the problems in this get carried out, you would distribute, simplify, and so on and so forth. All right, so now let's move on. And let's move on to number 18. So 18 is totally different from number 17 in the fact that we're just trying to graph the absolute value inequality. Okay, and again, graphs in this unit, it could be a number line graph or it could be the actual graph of this entire function. Okay, so the way we're going to know of what it looks like is if it said solve, then it's actually asking for the number line answer as far as where you either have open dots or closed dots and then the shading in between, like with conjunctions, or if you have shading on the outside, like with disjunctions. Again, just a reminder, conjunctions are with the word and, where disjunctions are with the word or. Okay? This doesn't have anything that says solve. You're not solving for x. And if you were to solve, there wouldn't be this y value here. It would be like a number value. It wouldn't just be a variable. So we know from all the context clues just stated that this is going to be just a graph that's like on the Cartesian plane, like the xy coordinate plane. So you're going to look at it like almost like a transformation, if you will. Okay, so imagine y is equal to the absolute value of x. And looking at number 18, it looks like it got shifted 4 units to the left. Okay, so no stretch or compression, just 4 units to the left, and it looks like that. But then it got shifted 2 units down. So 2 units down, the vertex is now going to be at -4, -2. And it still has a rise over run of 1. Okay? So it looks like this. But then at the very end, it's not equal to, even though I did have this as a reference as far as where to start. This is going to be all the y's that are greater than this blue graph right here. So basically, we're shading everything that's above this blue graph. And again, these go on forever, but the shading would be all up here. So that's how you do number 18. Okay. The only thing that I see that I mistakenly forgot to do is this has to be a dashed graph. So these lines right here, as it goes out to the left and right, because of the fact that the inequality did not contain equals, it would actually be a dashed line. Okay, just make sure you do that on your test as well. Okay, so now let's go ahead and go to number 19. So number 19 is a lot like number 18 in the fact that we're not looking for an actual answer to like a solve for x kind of problem. This is strictly going to be just graph the actual on an xy coordinate plane, this graph that you see here. So when we were doing y equals mx plus b back in Algebra 1, we had to get y alone first. So I'm going to have to move this 2 to the left side by subtracting it. So I'll have -2, and then it's written like this. X, the absolute value of x minus 1, -2 is less than or equal to y. Now, most people would read this kind of like right to left and would write y is greater than or equal to x minus 1 is in the absolute value, and it's -2. This is just easier in some respect to read because people are used to the y being on the left side, like in y equals mx plus b form. So now we're just going to graph what does y equals absolute value of x look like. And this will not be dashed because I, in fact, do have this equal sign this time. So we're going to shift 1 unit to the right and then 2 units down. So this vertex is at 1, -2. It still has a rise over run of just up 1 over 1, so on and so forth. And then we're going to shade greater than or equal to. So all of this that is greater than this line is going to be shaded. And sure enough, the line itself is going to be solid. Because again, we shade where the y says y's that are greater than this graph. So y's that are greater than are all the y's that we are shading. All right. So last but not least, we have number 20. Write an inequality for the graph. Okay, so this graph, I know it's a little bit difficult to read. So we have 2, 4, 6, 8, 10, 12. And this one, 2, 4, 6, 8, 10, 12. It's always a good idea to get the scale down first. 2, 4, 6, 8, 10, 12. Then 2, 4, 6, 8, 10, and 12. So it looks like not 2 or 4, but in between, this vertex is going to be at 3, and then down half a tick mark, and each one is 2. This is going to go down by 1. So the vertex is at 3, -1. So we already know shifting 3 to the right is going to look like this as far as with the x is concerned. And then shifting down 1, this is kind of what it looks like as of right now. We know there's not a negative in front because it didn't reflect downward and is looking downward, so it's still positive coefficient with A. We just now have to look at the rise over run, okay? So if I try to look at corners, okay, I could see that there's a corner right here at 2, 0. Oops. I can see that there's another corner, you could say at 6, 1. Or sorry, not 6, 1, 6, 2, because again, each tick mark is 2 units, okay? So let me change that to 0. That's good to remember. Each tick mark is 2 units, so it wouldn't be 2, 0. It would be 4, 0. So what you could do is from 3, -1, what was the slope that existed between those 2 points? So yeah, you can go back all the way to Algebra 1 if you want and do y2 minus y1, and I'm looking at these 2 points, over x2 minus x1. And a negative minus, or subtracting a negative is the same as adding, and then 4 minus 3 is 1. So in fact, it does look like it's 1 over 1. And if you didn't trust that one, you could use these other 2 points. You could have used still the vertex, but 6, 2. And you could have said y2 minus y1 over x2 minus x1. The top would give us 3, the bottom would give us 3, and the slope is still 1. So that means there's no vertical compression or stretch that goes here. If you did get a fraction like 1/2, then you would have put 1/2 because it would have shown a vertical compression by 1/2, and so on and so forth. Just in case you see that on the test, this would be a good way to look for the slope in that regard. Okay, so right now it does in fact look like my answer for this looks like this graph here. The only difference now is that we have to make sure that it is an inequality that we're in fact doing. So see, right now, this just being equals to, as far as right here is concerned, that would be if it was just the actual lines and nothing else. But because there's shading and they're shading above, we're going to say all the y's that are basically above or equal to, because this does look in fact solid. If it was in fact dashed, it would show it a lot more. And the ones on your test are much clearer. This would be your answer here. And you can write g of x, or if you choose to write y, that would be acceptable as well, because you're just saying y's that are greater than or equal to that graph. And that's it for the 16 through 20.